Hi, Nick Fox again with Beal University's Welding Department. Today we're going to go over the safe setup of OxyFuel cutting torches. Not always used for cutting. A very handy tool for welders to know how to use in their day-to-day welding lives. Alright, we're going to take this set of new torches and turn them into this set of setup ready-to-go torches. Just like this. We'll go over the step-by-step setup of these OxyFuel torches. First thing you want to do is take your caps off your cylinders. If they're stuck or binded, you never want to jam anything in here to open them. You can damage the valve. So you can tap them if they won't loosen up. I had these ones pretty loose to start, but again, always safe to not jam stuff in here. Oxygen is very reactive. Hydrocarbons and oxygen, when they mix at high pressures, can explode. So it is common practice to crack your oxygen cylinder with your non-dominant hand on the not opening side of your tank. You want to turn your head and crack your valve. What that does is it clears all the debris or any contaminants that may be in your cylinder. This is a brand new cylinder, but we still practice cracking our valves. Over here we have our oxygen regulator. It's going to go on our oxygen tank. It is standard right-handed threads with a female. It threads on here. It will not thread to our fuel gas, whether it be acetylene, propylene, or MAP gas. They are different. So let's set this on here, hand tight for now. Again, these are brass fittings, so we don't want to over tighten them. We will wear them out. The brass is soft and self-seals more or less. There's no O-rings or anything in this setup. This is our fuel gas regulator, and it has left-handed threads. If you look here at this nut, it has a dash in it or notch, and again that tells me it's left-handed thread, so you turn it to the left to tighten it. Move these hoses out of your way. So we want to hand tighten this. This oxygen again is a 2200 psi high pressure cylinder, and this acetylene is a 250 psi low pressure cylinder. They don't fill these to a PSI, they fill them to a weight. Just like when you get your propane tanks for your grill, they are weighing them. So this is a certain amount of weight of acetylene, where this is 2200 PSI. Let's go ahead and grab our spud wrench and tighten all our fittings. Again, we're not He-manning these fittings, we're just snugging them. Light pressure, okay, snug. Same with our acetylene, our fuel gas. Snug. All right, before we turn anything on, we wanted to shut our valves on our torch body. We'll put our cutting head on as opposed to our rosebud for preheating. A preheating torch head doesn't need but two valves, oxygen and fuel. A cutting head uses two valves as well, but we have a third valve now. So when you're using a cutting head, you can leave your lower oxygen valve on all the time. It will now be controlled, we'll turn it all the way on, by this valve. So this valve's off and this valve's off on a cutting head. This connection here only needs to be hand tight. We do not ever over tighten these fittings. The same with our torch tip holder. We'll go over some torch tips in just a second. So these are hand tight. These are tightened with a wrench. All our hoses are tightened. A good practice is to go through your hoses and check them for holes or burns. You can do that without looking, by feel, faster than you can visually inspect these hoses. Your hand will pick up on a cut, a bend, a nick pretty easy. Okay, these hoses are in good working order. I don't see any damage in the spots I can't feel. We'll keep those out of our way for a second. We want to turn on our oxygen and fuel gases. Again, to do so, I don't want to stand to the regulator side of my high pressure tank. If there was any sort of hydrocarbons, petroleum products within this regulator, it could explode when induced to high pressure oxygen. Also, we want to make sure our regulator is loose or off. We don't want the diaphragm in this regulator turned on when we open this valve. Same with our acetylene. This regulator is loose. Okay? Always open our valve slowly. For a high pressure oxygen cylinder, it's a 2-seat valve. We need to back seat it. Otherwise this valve can leak. So we don't need to He-man that either. Once it gets to the back seat, it's back seated. For acetylene, the rule of thumb is 1/4 to 1.5 turns max. You want to be able to shut off your fuel gas fast. If there's ever a fire or something happening, we want to be able to run by this and shut it off quickly. Pressure is going to be determined by the thickness of steel you're using, the type of gas you're using, and the tip. So tip size determines pressure: propylene, acetylene, and MAP gas. So again, you go to the chart, you look at your tip, and you set your pressures accordingly. We're using all the same size tips here in the classroom, and we recommend 5 to 7 for your acetylene and 30 to 40 for your oxygen. So again, I'm going to turn this up until I'm at 30 or 40 psi. You can see the needle move up. I can't move it down until I open the valve. So if I open the valve, you can watch this needle drop. I want to set a working pressure. The tip will determine that. So as the flow is flowing, I need to set the working pressure. Same for the acetylene. I can turn it up, but I can't turn it down unless I open a valve. And again, 5 to 7, we'll start at 5. When we open our valve, you'll see the needle drop. We need to set our working pressure, back up to 5, and shut it off. All right, so our torch setup is now pressurized and ready to go. We should talk about that quickly. I mentioned different types of fuel gas. Acetylene tips are one piece, like this one. This is a one-piece acetylene tip. And this is a two-piece MAP gas tip. It comes apart. So if you're not aware of what kind of cutting gas you're using, or you can't see your cylinders, you're running a piped-in system, this will be a telltale sign of whether you're using MAP gas or acetylene. So a two-piece tip for MAP gas and propane products mostly, and a one-piece tip for acetylene. All right, let's get our safety gear on now, and we'll go over lighting the torch and setting your flame. All right, now we got our jackets on. I do recommend stick gloves for torch cutting. We're just going to go over setting up the flame and turning it on. Again, torches produce UV rays, and you need the correct shield for cutting. A 5 is recommended. I like this style face shield. They make goggles and everything of the sort for that. Sunglasses. I still prefer this and safety glasses. You're going to need a flint striker for lighting your torch. You should never use a lighter. They can blow up in your hand. I have this on the table because back in the day, the old style acetylene tanks used to have a turn valve with a T handle, so you needed one of these to shut it on and off. All right, we'll throw this on. To light your torch, you want to crack your acetylene a very minimal amount. Otherwise, you may get a big flame or eruption. You don't want to let it run for any amount of time before striking it. Turn your flame on, light your acetylene. You can see here we have a carburizing flame, all this black soot burning off the flame. We want to turn our acetylene up until it burns clean. That is a neutral flame. We don't need to overdo it. It's waste and excessive. We'll turn this back until it's a nice neutral flame. Then we want to open our oxygen until we get some nice clean preheat cones. You'll see them form right here at the end of the torch tip. They are a nice, bright, defined blue. If we turn our oxygen up too much, we have an oxidizing flame, and you'll hear the torch get loud. This is not good for cutting. Here we have a nice neutral flame for preheating. We want to check our cutting flame by pressing the oxygen. The oxygen is on or off. It's no in between. Again, we can adjust our oxygen if needed. It actually looks really nice. Have a nice clean cone pattern. Okay. Then we would go to using this to preheat our steel if it was thick, and cutting our steel with the proper safety gear. To shut our torches off, we do it in the reverse order. We never want to starve our torch for fuel gas. So we shut our oxygen off first, and then our acetylene. Shutting off your oxygen first will cause a burn back situation. It's a loud popping sound. You're starving the torch for fuel gas. All right, we've gone over some torch safeties. There's a ton more techno babble I could go over, but if you want to learn that, you'll have to sign up for the classes. Thanks for joining me in this torch setup. We'll do another demonstration later where we go over plasma cutting as well. We'll compare the two. Thanks. Please like, share, and follow.